When I'm halfway through chapters, I take out my coffee and have my coffee. I don't even know what I'm saying, but I got coffee and I'm happy. All right, go. 2.4, kids, 2.4. That's like halfway through the unit. My name is Mr. Krause. I will be your answer key for this day. So we need to make a list of our perfect cubes, our perfect fourths, and our perfect fifths. We're not going to do too many fourths and fifths. We'll do some cubes though. And you should know these. So perfect cubes. The first perfect cubed is 1. The first perfect fourth is 1. The first perfect fifth is 1. Now, that's kind of boring. So let's not worry about those. See, that's 1 times 1 times 1. 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16. And 32. Let's do threes. 3 times 3 times 3 is 27. Times another 3 is 81. Times another 3 is 243. Ding, ding, ding. 4. 4 times 4 times 4 is 64. 4 times 4 times 4 times 4 times 4. I think that's 512, right? 256. And then 4 times 4 times 4 times 4 times 4, that's 512, right? No, 1024. Man. Is that right? Yeah, 4 of those is 1024. And then 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. 7 times 7 times 7, is that 343? I think that's 343. And 8 times 8 times 8, I think is 512. I'm not going to go past that. I'm not even going to go, oh, we need to do one more. 5 times 5 times 5 times 5. 5 to the fourth is 625. But that's about all you need to know. Whether or not you need to even know those, I'll tell you right now, the ones you're going to be using the most of are this one, this one, this one, and this one. And then the 16th, or the 4th, you might use this one or this one, and this one or this one. Those are the ones you'll probably be using the most of. Everything else, it's just kind of fun. Just kind of fun. All right, so to simplify a cube root. So let's do a little review. We know the square root of 9 is 3 because 3 squared equals 9. The square root of x squared is x because, well, it just is. Because squareds and square root cancel each other's. Oh, and then when we took care of these, we wrote this as x to the fourth times x. We wrote it as an even exponent and not. And then we said, okay, what is the square root of x to the fourth? It's x squared. So this is x squared, square roots of x. So that's squared. So now let's handle cubes. The cube root of 27 is 3. And I know that because 3 cubed is equal to 27. Now, just like a square and a square root cancel each other, a cube and a cube root cancel each other, and I get x. Just plain x. Now, x to the 7th. Whenever I have an odd exponent like this, what I'm going to do is I'm going to rewrite it using groups of 3. Well, I could write it as x cubed, x, but I'm going to put these two together. I'm going to make it x to the 6th. Just like over here, I could have put x squared and x squared. But what you want to do is you want to have the largest group of multiples, in this case of 3 that you can get, times x. So this cube root, now we're looking for, now this is where you got to be tricky. Now we're looking for groups of 3. How many groups of 3 are there in x to the 6th? Well, x squared. There's 2 groups of 3, cube roots of x. It's almost the same as this. Almost. So the fourth root of 81 is 3, and I know that because 3 to the 4th is equal to 81. A fourth root and a fourth cancel each other out, so that just leaves me x. And how close to the 9th power can I get? That's a multiple of 4. Oh, x to the 8th times x. So what I'm looking for here is how many groups of 4 are there in 8? Well, again, there's 2. So this becomes x squared fourth roots of x. How come that always happens with my 4s? Fourth roots of x. Okay. The fifth root, you probably get behind my head. The fifth root of 243 is 3 because 3 to the fifth power is 243. A fifth root and a fifth cancel each other out. Nothing's new here. How close, I decided to swing things up, how close to 12 can I get? That's a multiple of 5. The closest I can get is x to the 10th times now x squared. Okay. How many groups of 5 are there in 10? There's 2 groups of 5. It takes 5 x's. It takes 5 x's to cancel a fifth root. So I can cancel it twice. So this becomes x squared, fifth roots of x squared. Not sure what I wanted to put in that star, so we'll just skip that for now. Not a big deal. Negatives. Negatives! Okay, I know what I want to put in this here. If you have if you have square roots, you use I. Cube roots do not use I. All right, so I had to take a little note there. So I can take the cube root of -8. It's just -2 because I know that -2 times -2 times -2 is equal to -8. And so that's why I can take the cube root of negatives. It has nothing to do with I, and you're going to have to really go to handle on that. I is only used for square roots. Other than that, we're not going to use I. When we're dealing with cube roots, it's not a problem. The cube root of -27 is -3. The cube root of -125 is -5. And you can test this on your calculator. I can come over here and say, okay, what is the cube root of -125? If you forget that you can do that, there it is, pops out, boom. Now, if you try to do that, if you try to do the square root of -25, it'll say non-real calculation. Okay, you need I. You have a problem. Okay. All right. Well, that's the page 1. All right, I'm back. I just had to take a quick break, but you didn't notice that. All right, so we're going to deal with cube roots. Let me blow this up a little bit. I want to expand. I want to work on these so you can actually see what I'm doing. So we're going to do these one by one. We got a lot to do here. So you got to be careful. You're looking first for what the root is. Now, if you need to go back and look at those perfect cubes and fourths and things like that, you can do that. So we need, and we're looking for the largest perfect cube that goes into 54. In this case, it's 27. 27 times 2. 27 times 2 is 54, and so we can simplify that. The cube root of 27 is 3. So this becomes 3 cube roots of 2. Now we're looking for a fourth root. Now if you forgot, 2 to the fourth is equal to 16. So we're going to rewrite this as the fourth root of 16 times 3. And again, the fourth root of 16 is 2. Careful. Do you know how many kids are going to put a 4 there because they think it's a square root, not a fourth root? So you got to be really careful. Pay attention to what you're doing. Pay attention. Take care of precision. Be precise. The more precise you are, the better student you're going to be. So this is 2 fourth roots of 3. So now I'm looking for a perfect cube that goes into something that ends in 50. And I'm thinking, 5s and 25s and all that stuff. And the perfect cube that goes into 250 is... Did I give you enough time to think about it on your own? These are some things you should be thinking on your own. How about 125? 125 times 2. What is the cube root of 125? It is 5. So my answer is 5 cube roots of 2. Now guess what happens if you forget this? Oops, not that. But guess what happens if you forget the cube, or the cube root? Now you've written 5 square roots of 2, and that answer is not correct. No. Be very careful. If you forget this 3 here, you have gotten the wrong answer. 160, fifth root. Now if you go up and look at your fifth root, there's a very limited option. I think I gave you, I don't even know, what did I give you for options? I gave you 32, 243, and 1024. So your options are 32, 243, and 1024. Well, I'm pretty sure it's obvious that 32 has to go into this, because none of the others can divide evenly into something that's smaller. So 32 times 5. And what is the fifth root of 32? 2. So my answer is 2. Don't write square root of 5, write fifth root of 5. All right, so let's talk about some letters. So I'm looking for groups of 3. I'm looking for perfect cubes and groups of 3. Well, luckily for me, 27 is a perfect cube, so I'm just going to leave that the way it is. X cubed is a... Oh, I didn't have to do anything with this one. If I had paid attention, I didn't even have to do anything. It's all set up for me to start canceling. All right? The cube root of 27 is 3. The cube root of x cubed is x. Remember, you're looking for groups of 3. It's a cube root, so you're looking for groups of 3. And that's it. That's all I can do. So 3x cube roots of y. All right, 625. It should come as no surprise to you that we are going to be working... Oh, man, I don't have anything to do with this problem either. 625 is a perfect fourth. The fourth root of 625 is 5. Oh, wait, I do have work to do. It's a fourth root. All right, so we're going to rewrite this, and I'll show you where. This is fine, 625. That's 5 to the fourth. X to the fourth is not a problem either. But this y to the sixth is a problem. I want to rewrite this as y to the fourth, y squared. It's just going to make it a lot simpler to cancel. The fourth root of 625 is 5. The fourth root of x to the fourth is x. Remember, we're looking for groups of 4 now. For every group of 4, I can take out an x. And the fourth root of y to the fourth is y. So I end up with 5xy, fourth roots of y squared. Now later on, you're going to find out that that's really just a square root, but not today. Did she write the no. Have another error, kids. Sorry about that. I was cutting and pasting. Found an error. All right, moving on. Oh, yeah. 486. But again, it's a fifth root. I only have a few options. 32, 243, and 1024. And let's see. I can try 32. You're going to find out it doesn't work. It is 243. But you have so few to try. Just try it one or the other. So 243 times 2. Now I'm looking for groups of 5. Well, I can't do anything with A, so it doesn't even have a group of 5, so A to the fourth. But B and C, I can do a little bit with B of those. B to the fifth, B squared, and then C to the fifth. Okay. So the fifth root of 243 is 3. I can't do the fifth root of this. I can't do the fifth root of this. I can do the fifth root of that. It's just B. And I can do the fifth root of that. It's just C. So 3BC fifth roots of, now see what's left over, 2a to the fourth b squared. Alrighty then, where are we going? Where are we going? What are we doing? Close. Okay. Ooh, negatives. Now be careful. With square roots, we're going to deal with I. With cube roots, no I. So this is a cube root. So I need a cube root that goes, a cube that goes into negative 24. And I'm okay with negatives. So this should be negative 8 times 3, because this is a perfect cube. M I can't do anything with. N I can do something. N to the fourth times, ooh, not n to the fourth. N cubed times n. And p is already got a multiple of 3, so I'm okay with that. I'll leave it as p to the 6. Now remember, we're looking for groups of 3. Or, all right, first of all, the cube root of negative 8 is negative 2. The cube root of n cubed is n, and the cube root of p to the 6 is p squared. Remember, we're looking for groups of 3 again. So my answer is negative 2 n p squared 3 m n. Done. Moving on. Now you should probably pause this at some time and get a handle on what's going on. I have a fourth. I'm limited on my fourths too. My fourths are going to be 16, 81, 256, and 625. One of those has to go into this. Figured out yet? Oh wait, I'm just gonna enjoy myself some. I got this, by the way, a little Dunkin' Donuts coffee cup. It was nice, but I got K-cups upstairs. Ooh. I'm like a down-home K-cup Dunkin' Donuts. You don't care, do you? You're like, just get to the problem. Why don't you do the problem, huh? Why do I gotta do all the problems, huh? Yeah, I'm talking to you. Just kidding, man. I'm not yelling at you or anything. All right, if I have to help you, it's 625 times 2. Because 600 times 2 is 1,200. 225 is 1,250. Now we're looking for groups of 4. Ooh, groups of 4. So m to the 4th, m, that makes m to the 5th. N squared, can't do nothing with it. And p to the 20th, it's already a group of 4. So the 4th root of 625, obviously, is 5. The 4th root of m to the 4th is m. And the 4th root of p to the 20th is p to the 5th. Did you get it? I asked you a question, soldier. I'm no soldier. I'm just a math student. Leave me alone. 5m p to the 5th. 4th roots of 2mn squared. Ka-ching! Just checking my answers, kids. Just checking my answers. Forgot to check this one. Oh, look at that. I'm shooting 1,000. Bad 1,000. All right. Cube root, cube root, cube root. Oh, 216 is a perfect cube. Did you remember that? It's up on the list. By the way, when you're trying to find and simplify perfect cubes, first try the number. If that doesn't work, then try all the other numbers. But first try the number. I get so many kids try to simplify this, like, oh, I don't know. What goes in there? 32, 42, added 16. I don't even know. Try the number. Negative 216 is a perfect cube. X squared, can't do anything with it. Y to the 6th y, and then z I can't do anything with. So, back to purple. The cube root of negative 216 is negative 6. And this has 2 groups of y, so it's y squared. So it's negative 6 y squared, cube roots of x squared y z. Still checking my answers. Yay! What's next? More? All right, let's get these done. So, that negative, that's sort of bothersome up there, but I know that's really negative 1. This is going to be h cubed h j to the 9th, that's already a multiple of 3, L6, L2, that makes 8, and k to the 6th. Should have picked better letters like K, E, and N. Get it? If you don't, look up what my name is. All right, the cube root of -1 is -1. The cube root of h cubed is h. The cube root of j to the 9th is j cubed. The cube root of L to the 6th is L squared. And the cube root of k to the 6th is k squared. Remember, looking for groups of 3. So it's negative. You can write -1 if you want. H j cubed L squared k squared cube roots of what's left over. I got to find it. I got to see. H is left over and L squared. Lost it for a second. H L squared. 2 left of these. Square root. Oh, we're back to a square root. How easy is that? That's simple. Square root 25 times 3. You're going to be wanting to go back to these. N to the 4th. That's as close to n to the 5th as I can get. We want even numbers. N times p to the 8th is fine. And then q I can't do anything with. So square root of 25 is 5. The square root, remember looking for groups. Remember there's really just a 2 here. You just can't see it. It doesn't look much like a 2. That's okay. N squared. And how many groups of 2 are in p to the 8th? 4. So 5n squared p to the 4th, 3nq. One last one. A 4th, a perfect 4th. Well, there's not that many 4ths. Go back and look. Take a look. I'll be partaking in some cafe. It's 90 degrees out, by the way, but you never have enough coffee. So 81 times 2, c to the 4th, d to the 4th, d squared. That makes 6. And e, 12 is already a multiple of 4, so I'm already good there. The 4th root of 81 is 3. The 4th root of c to the 4th is c. The 4th root of d to the 4th is d. And the 4th root of e to the 12th, how many groups of 3 are there? Or how many groups of 4 are there? There are 3 groups of 4. So I end up with 3c d e cubed, 4th roots of 2d squared. And that's what I got. Okay, I think we got 1 page left. Somehow we jumped back. 1 page left. Ooh, www.algebra2commoncore.com. That'll take you to our NK Infinity. Don't forget we are at www.nkinfinity.com. But that'll take you there. Whoa, look at there. Look at there, simplifying radicals with your besties. All right, so this was actually going to be, or is going to be, a classroom activity. So really, this is your time to practice and shine. This is your time to do some work on your own. So at this time, I would just I'm going to do them, but, you know, it's like watching a trained monkey. You can watch a trained monkey clap all day long, but you're not going to learn anything unless you try it on your own, chillin'. That's about what math's all about. You got to try and practice and try on your own. Otherwise, you ain't going to get any better. And watching me do these does not improve your score. Making sure you got the right answers or finding out where your mistakes or where you made your mistakes is where you're going to really, really, really start to improve your scores. Okay, you guys ready? So pause. If you want to do one at a time, pause it now, come back. I'll tell you when to pause every time. I'll say, pause. No, really, pause. Oh, you did? I'm sorry. All right, so 1/2. Can't do anything with the 1/2 right now. Cube roots. All right, cube roots. So we're going to do this as 8 times 2, because 8 is a perfect cube. F cubed is a perfect cube. G is not. H cubed, H squared. Hopefully you made the first step right. Let's try black. The cube root of 8 is 2. The cube root of f cubed is f. The cube root of h cubed is h. So now you got to be careful. I've got 1/2 times 2. So you got to take care of that first. 1/2 times 2 is just 1. All right, you can write a 1, or I don't have to write anything there. It's really just f h cube roots of 2g h squared. All right, you and your besties, how'd you do? I'm your bestie today. Just sounds really awkward. Pause. Also, I'll make a face, so if you can pause it with my funny face, and like you just got to look up and laugh at me all the time. What do you mean you're laughing at me all the time? What do you mean it's a funny looking face all the time? I don't even like you, meanie. You know who I'm talking to. You guys ready to roll? I know. You guys are nice. You wouldn't call me what you would. All right, we're going. -3/5. Cube roots of. Hopefully you picked 125 times 2. That's 250. F cubed g h cubed h squared. Oh, this is a lot like that last one. The cube root of 125 is 5. The cube root of f cubed is f. And the cube root of h cubed is h. Now, I know you guys are only in, 10th and 11th grade, and you can't multiply fractions yet, which is really embarrassing. But -3/5 times 5 is -3. The 5s just cancel. Really? Is that easy? -3f h cube roots of 2g h squared. There's like 5 people out there go, what you talking about, man? I can multiply fractions. Are you crazy? And then the rest of the 99% of the other people go, yeah, he's right. Can multiply fractions. I don't even know what I'm talking about with those. All right, so let's see what we got here. Pause. You're back. Hey, how you doing? Good to see you. Hope you paused it at the right time. Cube roots. So the cube root that goes into 54 is 27. Now, there's a reason we do a lot with cube roots, because those are what you're mostly going to see. Not a lot of force, not a lot of fish. You're mostly going to see square roots and cube roots. But you should be aware that the others exist, and that's why we do them. Looking for multiples of 3, so that's r to the 6th. That is a multiple of 3. Looking for multiples of 3 here, so that's t to the 6th and t squared. All right, the cube root of 27 is 3. It's not 27. It's 27 times 2. I forgot the times 2. Stop yelling at me. I make mistakes. R to the 6, r squared. T to the 6, t squared. All right, so now you got to multiply 2/9 times 3. Well, 2/9 times 3 is 6/9, otherwise known as 2/3. 2/3 r squared t squared cube roots of, don't forget the 2 like I did, 2t squared. Make sure I got the right answer. I do not. I forgot the stuff I took out. Got a few corrections to make. Alrighty. First things first, we're going to simplify this puppy. So let me really blow this up. Can I blow this up anymore? Am I up as high as I can blow this up? View, zoom. I'm at 488%. I'm changing that to 600. 500 is as much as it goes. Okay, whatever. That's as high as I can blow it up, kids. All right, so hopefully you can see that. So here's what we're going to do. 10 goes into 160 16 times. The numerator has more f's, so we're going to get rid of these 2 f's. We're going to get rid of 2 of these. That's going to leave me 6. The g's are just going to cancel. And the numerator has 3 more h's, so we're going to leave 3 there. So notice the whole denominator is gone. So what I end up with is, let me do it here. The cube root of 16 f to the 6th h cubed. And I got to simplify that. So now we'll do the cube root of 8 times 2 f6 h cubed. All right. The cube root of 8 is 2. The cube root of f to the 6th is f squared. And the cube root of h cubed is just h. So I end up with 2f squared h. Oh, look at that. I forgot the cube. Cube roots of 2. Crazy. We got 2 problems left. All right, so let's simplify first. All right, so no number goes into 8 and 27, so you can't do anything with those. The denominator has more d's, so that leaves me 8 down here. G's I can't do anything with. E's I can't do anything with. Is H I can't do anything with. F. The numerator has more F's. It has 4 left. So what I end up with is, and I'm going to split this up. The cube root of 8 G H F cubed times F all over the cube root of 27 D to the 6th d squared e to the 6th e. Man, this is ugly. All right, so in the numerator, I end up with, let's see, the cube root of that is 3, and the cube root of that is f. So the numerator is 3f cube roots of GHF. And the denominator, cube root of that is 3. The cube root of that is d squared. And the cube root of that is e squared. So the denominator is, oh, by the way, the cube root of 8 is certainly not 3. I don't know what I was doing there. It's 2. So 2f. I would have solved my error in a minute. So this is 3d squared e squared cube roots of d squared e. Now, if you really want to make that look nicer, it's 2f over 3d squared e squared cube roots of GHF over d squared e. That's what I like to call a really annoying problem. Last problem. Cubes. First I'm going to simplify. Numerator's got more x's, it's got 6. The numerator's got more y's, it's got 5. Can't simplify anything, so I'm going to rewrite this as 27 times 3 x to the 6th y cubed y squared. The denominator is just the cube root of 125, which in fact is a perfect cube, which is nice. So, cube root of 27 is 3. The cube root of x squared, x to the 6th is x squared. The cube root of y cubed is just y. So the numerator, I end up with 3x squared y cube roots of 3y squared all over 5. Perfect. And that's it. All right, kids, if you haven't subscribed yet, please do so. I'd love to have you as a subscriber. You'll get notifications all year long of all the different kinds of problems we are going to be doing. And in every unit and every chapter. And when it comes down to the review at the end of the year, there's nothing better than the review that Miss Newman and I put together. It is some amazing stuff. So I hope you subscribe. I guarantee you all year long it will be incredibly helpful. I'll be giving you calculator tips all year long. I'll be giving you test-taking strategy tips all year long. We'll be doing some test prep before each test. So hopefully you subscribe. All right, guys, it's been fun. Catch you on the flip side.